Hello and welcome everyone to my channel Code with Ease. As part of the array series that we are doing, today we are going to solve best time to buy and sell stock part 3. We have already discussed about the part 1 and the part 2 version of this question. You can check the links in the description and I'm also going to link it up above. And this is the Leetcode hard question. So let's look at the problem statement first. We are given this array prices where prices I is the price of given stock on the ith day. We have to find out the maximum profit we can achieve, but we can complete at most only 2 transactions. So we are given this limitation of being able to do only 2 transactions in comparison to the previous questions where we had the allowance to do more transactions. You may not engage in multiple transactions simultaneously. That is, you must sell the stock before you buy again, which means we are not supposed to hold the stock. We have to sell it off before buying another one. Okay, so let's quickly look at the example to have a better understanding. This is the array which is given. Every number in this array is basically the price of a stock on that particular day. So it's the output is 6 because first of all they're buying on day 4 when the price is 0 and they're selling it on day 6 when the price is 3. The total profit collected is 3. Then they're again buying on day 7 when the price dropped to 1 and they're selling it the next day when the price went up till 4. So again the total profit collected is 3. So initially we got 3 units of profit, and again now also we got 3 units of profit. So 3 plus 3 is 6. Hence the total profit is 6, and we are also abiding by this condition that we can at most do only 2 transactions. So there are only 2 transactions that has been done. If you look at the third example, here the output is 0 because by the looks of the prices, it is going in the ascending order, like the price is reducing in every day. So it starts with 7, then goes down to 6, then 4, 3, 1. So obviously if this is the pattern, we will not be able to achieve any profit, because if we buy it at a higher price, we will have to sell it off at a lower price, hence rendering no profit to us. So that is what the question is. The biggest concern or the condition is 2 transactions at most, not more than that. Okay, so now let's see what can be the approach for solving this. So here's the array that we have taken, and first of all we'll discuss about the brute force way of solving this. So as we know that maximum number of transactions is 2. If we take a look at this example which we had seen before, so here we see that on day 4 the purchase was made and on day 6 the stock was sold and the profit was 3. So day 6 is basically till here. On day 7 means 1, they have bought at 1 and sold at 4. So if we try to divide this array into 2 parts, so we can say that from here, from the beginning till this point, till this index, the profit achieved is 3, and for 1 and 4 again the profit achieved is 3. So something on the similar lines we are going to think of. So we can think like, let's say we have this array and we have an index I, and we are going to break this array into 2 parts such that 0 to I will be one part of the array and I plus 1 till the end will be another part of the array. The intention behind this is from 0 to I we are going to calculate some profit, let's call that as P1, and from I plus 1 to n we are going to calculate another profit, let's say that is P2. So at the end how we will calculate the profit is, it will be equal to, we'll use a math.max function. In that we'll check whether whatever current profit we have got, if that is greater, or a combination of this P1 plus P2 is greater. In that way we are always going to store the maximum amount of profit done or achieved so far in this profit variable, and this is going to run inside a for loop, and this is going to be determined by the value of the int I, like we always do that, int I equal to 0 and I less than n and so on. So this is going to happen for every ith value. P1 will be 0 to I, 0 to I will be one part of the array, and I plus 1 till n will be another part of the array. So from these 2 sub parts or sub arrays we will calculate the profit and add it up. Now the question again remains, how do we calculate the profit for every sub array? So this also will require another for loop. So this P1 and P2 can be put inside some method, let's say find profit. So in this find profit method we can pass in whatever the array we have, and we can pass a start and end pointer. The start and end pointer is what is going to be determined by this 0 and I. So initially it will be 0 and I, and for the second call it will be I plus 1 to n. So we are inside this method, what we are going to do is we are going to calculate the profit from this range, like start to end, whatever the array we have got, we'll calculate the profit over there. I have linked up the pseudo code of this brute force solution in the description, you can check it out. So now coming to the main part, so we have done all of that. Now we are going to iterate through the arrays. So here we'll have one for loop. Inside this we are going to have a for loop which is going to run from 0 to I and then I plus 1 to n. So now coming to the main thing, the time complexity. So what is going to be the time complexity for this? Very obviously it is going to be exponential. It is going to be order of n square, because at first we are going to traverse there in the outer for loop, and then when we are doing the method call separately for P1 and P2, we are again doing a method call for one half of the array and then another method call for another half of the array. In a way, we are doing the traversal again for the entire array in two different method calls. So as a result of that, this is the time complexity, and space is constant. So that's not acceptable. So we might want to optimize this approach. So let's see how do we do it. So now we'll talk of the optimal solution for this, and for doing that, as we saw in brute force, the time complexity was order of n square and space was order of 1. So now to optimize this, let's take up some space and see if we can optimize it. So what we will do, like we discussed about that P1 and P2 arrays, right? Not arrays, but two different method calls to calculate the individual profits. So instead of doing two different method calls, we'll take two different arrays. So maybe we can call one as the left array and another as the right array. Okay, and these are going to be the of the length same as the original array. What we are going to do is, in each of these array, we are going to store profit incurred so far. Both of them are going to store the profit only, but in the first array, in the left array, we will store the profit incurred so far by doing a traversal in the forward direction, like from 0 till end. And in the right sub array, we will store the profit incurred so far, but in the backward direction, like going from the back. So this is going to be the step number 1. First of all, populate the left array and the right array by putting in the respective profit at every index. How we are going to do this? How we are going to do this and why we are doing this, we'll come to that in a while. So after doing this, the next step will be to add the left of I and right of I and then calculate the profit. This is something which we have earlier seen in the brute force way, that profit equal to math.max of left of I and right of I and the current profit, something of that sort. This is ensuring this P1 and P2's thing what we were doing in the brute force, that one set of profit will get from here and one other profit will get from here. So as a result, we are doing only two transactions. Now coming to the breakdown of what is going to be in the left array, how we are going to store the profit incurred so far. When we are traversing the array in the forward direction, we'll assume every index to be a potential selling price. Means whatever values we are seeing in the array, let's say if that is the potential selling price, what can be the profit that I can achieve? Now we know that to calculate profit, we always do selling price minus cost price to get the profit. So now that we have the selling price with us, to calculate the profit, we need, what is the next thing? The CP. So we'll maintain a variable called minimum CP when we are traversing in the first loop. For populating the left array, we'll maintain this variable. What is this minimum CP going to be? Initially it is going to be this element itself, the first element itself, but afterwards this variable is going to change depending on the current element. So minimum CP, as the name suggests, will use this math.min function and will calculate whether this CP is the minimum, I mean the whatever we have it stored over here, if that is, this is the minimum, or the initial element, like the number before this. So I can say this like the priv element. So that is one thing. We'll calculate minimum CP. Now once we have the CP with us and SP is anyway the current element, like the ARR of I, simply we can calculate the profit and put it in the left array at its individual indexes. So this is the first part, which we are going to do it in the first for loop. Similarly, we are going to populate the right array also. Okay, so now talking of the right array, just as we did it in left array, we are going to do the opposite. So in this, every index, instead of treating as a potential selling price, we will treat every index, every price of that stock as a potential cost price, and then determine what is the maximum SP that can be achieved. So here's the thing, like for profit, CP, the cost price has to be minimum, hence minimum CP, and for profit to be maximum, we need the maximum selling price. At what price can we sell it off, and that price has to be the highest possible price. So for this thing, we will need this maximum SP. And since for populating the right array we are traversing from backwards, initially this maximum SP can be the last element itself. And from here, we are going to treat every element in the backwards direction as a potential cost price and figure out which one is greater. As in, if max SP is a variable, we can say math.max of whatever this max SP, if that is greater, or the element plus 1 means that just the next element. So if we are over here, we'll just check if the maximum SP, whatever we have collected so far, that is 4, if that is greater, or the next element. So we'll just check. In this case, we were checking the previous element and the minimum CP. Here we'll check the existing max SP and the next, just the element to the right side. And then we are going to keep a track of this variable. That is one thing. And second thing, again same thing, to calculate profit we need to have this max SP whatever we have minus the current element. So in that way, now what we will have at the end, we will have two arrays populated with all the possible profits. Then we will do one more final iteration, another for loop, in which we are going to add the element at individual position of I, and then do it like left I and plus right I, and then calculate whatever is the maximum profit that we have achieved so far. So now let's do a dry run on this to understand. Okay, now we'll start with the dry run. So it's a known fact that for the first element and for the last element, the profit is going to be 0. Okay, so we are always going to start from the second element when we are traversing this side, and from the second last element when we are traversing this side, because these are the elements at the edge. If we are at 1, what do we sell at? We have to buy at 1 and sell at 1, hence 0. And the same with the last element. Okay, so initially it will be 0. Okay, now minimum CP is equal to 1. So these are the variables that I have written. Profit initially 0, minimum CP 1 because that is the first element, maximum SP will be 5 because that's the last element. Okay, so what's the first thing that we are doing? We are comparing whether the minimum CP is lowest or the previous element. So in this case, it will be remaining as 1 only. Then we'll calculate the profit. What is the selling price? So 2 is the selling price, the potential selling price. So 2 minus 1 is 1. So now the profit will become 1. We'll populate that into this array. Then we'll move to 3. Then we'll check whether minimum CP, whatever we have stored, if that is lower or the previous element is lower. So minimum CP will still be as 1 only. So now we'll change this. So 3 minus 1, it is going to be 2. So now profit becomes 2. We'll move to 4. Same thing, minimum CP will remain as 1. 4 minus 1, now the profit becomes 3. So it became 2 and then 3. So we'll populate that as well. And finally at the last element, minimum CP remains as 1. 5 minus 1 is 4. So the maximum profit achieved in this, in every index can be in this fashion. So firstly it is 0. When you are buying at 1, selling at 2, profit is 1. Buying at 1, selling at 3, profit is 2. Buying at 1, selling at 4, profit is 3. Buying at 1, selling at 5, profit is 4. So it's always the thing like buying at the minimum CP whatever you have and selling at the current element wherever you are, and then calculate the profit. That's it. Next, what we will do? We'll do this right array. So initially this is going to be 0. Max SP will be 5. So we'll do the comparison. So max SP will remain as 5. So 5 minus whatever the current element is, because that is the potential CP now. So 4 is a potential CP. So 5 minus 4 is going to be 1. Okay, so now this becomes reinitialized, so it will be 1. Then we'll move to 3. So in this case, max SP is always going to be remain as 5 only because that is the maximum. So 5 minus 3, it's going to be 2. Then we are at 2. So max SP 5 minus 2, it is going to be 3. And finally we are at 1. So max SP minus 1, 5 minus 1 is going to be 4. Now the final part is to calculate the total profit. So in that we told left of I and right of I we are going to compare. We are going to just add this up and check it with our existing profit. Okay. So if you see, whatever numbers you are going to add, it is going to be 4. 0 plus 4 is 4, 1 plus 3 is 4, 2 plus 2 is 4, 3 plus 1, 4 plus 0. This is actually because this array has been in a increasing order. So our task at the last will be to check whether the combination of left of I plus right of I is greater, or the given profit, whatever some profit variable we are going to have, if that is greater. These two things we have to just check using the max function. So at any given point in time when left of I plus right of I is smaller than the given profit, it will remain as is, just as how the max function works. So hence, as a result of this, the total profit that comes out of this transaction is 4. We are doing 2 transactions at any given point in time. So that's all about the dry run. Now let's see the code implementation for this. Okay, so now we are going to start with the code changes. So first of all, we'll have this additional arrays, the left and the right arrays, which are going to be of the same size as the prices array. We'll also store the length for this. Next, we'll define this profit variable, and that is what we have to return. So initially this is going to be 0. Also, we would need 2 more variables, the min CP and the max CP. So min CP is going to be the first element of this. So which is going to be prices of 0, and the max SP is going to be the last element, which is prices of n minus 1. So with all of that, let's now write the first for loop to fill in the values inside the left array. So we are going to start the traversal to in the forward direction, but we're going to start from the first element itself. Okay. So the first thing is to calculate the minimum CP. So for doing that, we are going to use the math.min function. So either min CP is going to be lower or the element just before this, which is prices of, which is the current element itself, which is prices of I. That's the first thing. And secondly, now we have to populate the left array. So this left array at the ith position. One more thing I would like to reiterate, because we're starting from the first element. So now you might be thinking that what will happen to the first element, like the left of 0. That is going to be 0 only, because as we discussed, left array and the right array are only going to store the profits. The initial profit is always going to be 0. Hence, it will be anyway initialized to 0. So we are starting from the first index. Inside this, we are going to put the profit. So what is the profit? How will it be calculated? Math dot max of the previous element, like we discussed, which is going to be left of I minus 1. Either that, if that is greater, or we are going to do the profit calculation, which is SP minus CP. What is the SP? Prices of I, the current element. And what is the CP? Min CP. So this expression is going to give us the profit, and this is going to give us the previous element, and we are going to check whichever is greater. So that is going to be stored as the profit in the left array in the respective indexes. That's it. So this is all about the first for loop, in which we are doing the traverse in the forward direction. Second for loop, we are going to do it in the reverse direction. So we are going to start from the second last element. Then instead of min CP, we will be doing it as max SP. This will change to max. Again, it's the same thing. We are going to check it whether the current element, the prices of I, is greater, or the whatever max SP we have, if that is greater. Then here we are going to put the values inside the right array, and here the same thing we are going to do, but in case of this, it is going to be right I plus 1, because we are doing a traversal from the backward side, right? So the first element and the next element, the element to the right. So that is going to be compared, and again here it will be just the opposite, and in this the SP is already what we have, the max SP, and the current element will become the potential CP. Hence, we are going to do prices of I. Finally, the last for loop is going to calculate the total profit. So we are going to do one more traversal. In this, the profit will be calculated, which is again going to be math.max of whatever profit we have, whether that is greater, or you remember like the P1, P2 thing. So in this case, it will be left of I plus the right of I. That's it. Finally, we will return the profit. Okay, we'll run the code. We'll submit this. Okay. So yeah, that was all about this question. Best time to buy and sell stock, part 3. I would highly recommend to check out the part 1 and the part 2 of the same question, because in that way it can form a solid base. Hope you guys have enjoyed the session today. Do let us know in the comments below if you guys have any questions or doubts, or you want to share any feedback on this video. If you have enjoyed the session so far, do hit the like button so that this can reach out to many more people. And if it does, it just gives us enough motivation to put out more such content. Also, if you are looking forward to more videos like this, please don't forget to subscribe to the channel and press the bell icon next to the subscribe button to never miss an update on our upcoming videos. Thank you so much for watching.